Assalamu alaikum. Welcome to the fifth lecture of DSP. Today we are going to discuss the fast Fourier transform. The equation of fast Fourier transform is x of k is equal to summation n is equal to 0 to n minus 1 x of n e की power minus j2 pi k n over n. We have two types of data, sorted data and unsorted data. In worst case analysis, we have to do O of n number of searches when we have unsorted data, and the searches reduces to log base 2 of n when we have sorted data. This can be related to fast Fourier transform and discrete Fourier transform. In fast Fourier transform, we have to do less number of calculations as compared to the discrete Fourier transform. Let's take the same example from the previous lecture. We have a signal equal to x of n is equal to 2 minus 4 3 1 minus 2 0 3 and 1. Here we have n is equal to 8. As we previously calculated the values which are listed here, now we will calculate the same values by fast Fourier transform. In fast Fourier transform, we separate out the data on the basis of even and odd numbers. 4, minus 4, 1, 0 and 1 will be made as separate data, and odd numbers will be made as separate data. We will apply the Fourier transform on both of them and then add them according to the equation given in the next slide. We have to calculate the fast Fourier transform of the both even and odd terms separately as given in the equation, and then we will add the both Fourier transform of even and odd series with the formula x of k is equal to even plus w n of k into odd terms. This will reduce the number of multiplications and number of additions of the transform. This is how we can merge even and odd number of data and by 2 half number of the samples. Here is the example of calculating fast Fourier transform. We have separated out even and odd number of data and have calculated the Fourier transform of each data. Now the output x of 0 is equal to 6, and we have to multiply it with the first output of the second set, that is even set. Minus 2 will be multiplied by omega 8 of 0 and then added in the x of 0, that is 6, and we will get 4, which is the same as we have achieved in the discrete Fourier transform. We will do the same with all the data given here, that is x of 1 will be added after multiplying it with omega 8 1 and then added in 4, which will give out the same result as the discrete Fourier transform. Now we will reduce our samples to two data parts, then even number of points 2 and minus 2 and odd number of points 3 and 3. This will make total additions of 24 and total multiplications is equal to 16 in worst case. If we have an audio sample, we have 4k frequency of it maximum, and some number of samples will be equal to 8k. In 1 minute, 8k samples into 60 is equal to 480k hertz, and in 10 minutes 4.8 million samples. More samples is equal to more good resolution frequencies. It means that if we increase the number of samples, we can increase the resolution frequency of our signal.